In this video, we will talk about what higher order derivatives are. So I want to begin with the definition. So what's called the second derivative of f of x, which is written as f, and I put a double apostrophe of x, and I sometimes will say f double prime of x. Or I can write it in my notation as d2f over dx2. What this means is it's the derivative of the derivative of f prime of x. Similarly, the third derivative of f of x is going to be written as f. I'll put 3 of these apostrophes, or f triple prime of x. I could also write it in my other notation as d3f dx3. And this is going to involve taking the derivative 3 times, or taking the derivative of the second derivative, which overall would be 3 derivatives. All right, and similarly, I could say the nth derivative of f of x, which would be written as f. So the convention is usually after we get to 3 derivatives, we stop putting apostrophes just because it gets hard to count. And we switch to doing f, and then the number of derivatives, we put it in a parentheses in the exponent. So I'll write n like this. So that stands for the nth derivative. Or I could also write it in my other notation as dnf dxn. And this is the derivative of the n minus first derivative. So f, I would put in parentheses n minus 1, and then parentheses x. And the convention is I usually switch to this notation for multiple derivatives as soon as we get to 4. So let's end this video with a quick example relating to physics and motion of particles. So it says the position of a particle, s of t, traveling along the x-axis is s of t, so s of t is a position function, equals 2t to the third minus 3t minus e to the t power after t seconds. And part A says to find the velocity, which we'll call v of t. So velocity is the rate of change of position, or the instantaneous rate of change of the position. So that means it's the derivative of position, because instantaneous rate of change means a derivative. So okay, so I need to do the derivative of my position function. So for 2t to the third, that 3 will come down. I'll get a 6. And then t squared when I subtract 1 from the power. And then minus the derivative of 3t is just 3. And then minus, and then the derivative of e to the t is just e to the t. And that's my velocity function. It's just the derivative of position. Okay, acceleration is the rate of change of velocity. So it's the derivative of velocity. So it's d dt of v of t. Or I could also write that's the second derivative of position. Second derivative of position, that is acceleration. All right, so we need to do the derivative of our velocity function. And if we did that, derivative of 6t squared is 12t. 3 is a constant, so the derivative of minus 3 is 0. And then I'll get minus the derivative of e to the t is itself. Okay, that is going to be my acceleration. Okay, maybe let me write v of t here and include all of this in the box. And I'll write a of t here and box this whole thing. That's my acceleration. All right, so returning to our goals for the section, we finished our last goal, which was to compute higher order derivatives. And as we'll see later in the class, the derivative combined with the second derivative will tell me more information about the shape of the graph. So not only if the graph is increasing or decreasing, but how it's curving.